Assalamu alaikum, dear students, class of 9. Today we are going to discuss the types of matrices. There are almost 12 types of matrices which are discussed in your class of 9th mathematics. So the first one is row matrix. When we are going through our types, the first one would be row matrices or row matrix. What is row matrix? The matrix having only one row is called row matrix. The columns may be 2 or more than 2, but the row would be only 1. For example, this is a row matrix because it has one row and columns, one column. The order is 1 by 1. This is the row matrix because it has also one row and 2 columns. But the row is 1, so it's called row matrix. What about this matrix? Is that a row matrix? No, it's not a row matrix. Why? Because the number of rows in this matrix are 2. It's a 2 cross 2 matrix, so it is not a row matrix. The second type is the column matrix. What is the type of matrix which is called the column matrix? The matrix having only one column is called a column matrix. Let's take an example. This is also an example of column matrix because it have one column and one row also. Another example of column matrix is 1, 2. See, only one column. The rows are 2, but the column is only 1. So it's also a column matrix. And the third one would be 1, 2, 3 because it have one column. And how many rows does it have? 1, 2, 3. This is a column matrix. Having only one column is called a column matrix and having only one row is called a row matrix. The third type discussed in this book is rectangular matrix. Whenever you are discussing the types of anything, then you must keep in your mind that you have to take the meaning from the type, the labeling of the type. For example, it is labeled that this is a rectangular matrix. So, rectangle. You are going to take the name rectangle from it. Then you will assume the picture in your mind, or you will imagine the picture of rectangle in your mind. Then it would not be forgotten from your mind. It would be kept for very long time in your mind. Okay? As we know that rectangle is always be like this or this. So the type of matrices whose shape is like this or this is a rectangular matrix. This is just for convenience. For the definition, you have to keep in your mind that number of rows and number of columns in any matrix are not same. then that would be a rectangular matrix. For example, this matrix. This matrix is a rectangular matrix because the number of rows are 3, whereas the number of columns are 2. It's a 3 by 2 matrix. So it's a rectangular matrix. Let's take another example of a rectangular matrix. 780 are the entries, and there are 3 rows and 1 column. So it is also a rectangular matrix because it has 3 rows and 1 column. The number of rows and number of columns are not equal, so it's a rectangular matrix. And if you have to see the shape, the shape is also like a rectangle. Okay. Sorry. Let's move further. Now we will discuss about the square matrix. The square matrix is basically a matrix in which the number of rows and number of columns are equal. Just like a square, the shape of square. As a counter example, we can take A, B, C, D. Number of rows and number of columns in this matrix are 2. This matrix is 2 cross 2 matrix. You can see 2 rows, 2 columns. So it's a square matrix. Another example of the square matrix we can take is this. It's a 3 cross 3 matrix. It can be 4 cross 4, 5 cross 5, 1 cross 1. 1 row, 1 column. 3 rows, 3 columns. These all are square matrices because the number of rows and the number of columns in each of the case is equal. Now we will discuss about the null matrix. Null matrix is also called zero matrix. It's a matrix which has all of its entries 0. It is denoted by O. Simply denoted by O because all of the entries are 0. This is a null matrix. Now we will know about the transpose of a matrix. What is a transpose of a matrix? If we have a matrix A and then we will change the rows into columns, or we want to change the columns into rows, the matrix then obtained is called transpose of a matrix. Transpose of a matrix is denoted by, let's suppose we have initially a matrix A. Then the transpose of A would be AT, denoted by A and T. How we will get it? We will change the first row into column. 1, 2, 1, 2, 3, 4. This is basically transpose of a matrix. For instance, we can take another example. If A equals to 1, 2, 3, 2, 1, 0, minus 1, 4, minus 2, then transpose of A would be, the first row would be written horizontally. No, sorry, the first row is written horizontally. We will change it vertically. We will write it like this. 1, 2, 3. Then it comes the second row. 2, 1, 0. We will change it into 2, 1, 0 in a vertical form. The third row. Here comes the third row. Yeah, now this matrix which is obtained is called transpose of the matrix A. If we have C equals to 0, 1, then the transpose of C would be 0, 1. One thing which we keep in mind is that if a matrix has order 2 by 3, then its transpose have the order 3 by 2, completely opposite to that of the original. In the matrix C, the order is 1 cross 2, 1 by 2, the one row and 2 columns. And the transpose has the order 2 cross 1. So this is what I was saying. Now we will discuss about the negative of a matrix. Negative of a matrix. If I have any matrix and I would change the sign of all of the entries of that matrix, then that would call negative of a matrix. For example, if I have initially a matrix A with the entries 1, minus 2, 3 and 4, and I want to change the sign of all of the entries, then the matrix which I get would be negative of A. The 1 would be changed into minus 1, 2 would be changed into minus 2 would be changed into 2, 3 would be changed into minus 3 and 4 minus 4. This is actually negative of the matrix A. Okay. Now we can take another example. 0, 1, and negative of C is 0. We cannot change the sign of the 0, but we can change the sign of 1, minus 1. Okay, this is what the negative of a matrix is. Okay, this is the 7th category. Now we will move towards the symmetricity. If we want to check the symmetricity of matrices, what should we do? Symmetric matrix. Which matrix would be called a symmetric matrix? Yes, for sure. There are two conditions. First, it is important that the matrix would be a square matrix. It means that the order would be same. Like if the number of rows are 3, then the number of columns would be 3. Then we can find a symmetricity of any matrix. And what is the condition of symmetricity? The transpose of A would be equal to A. First condition is it would be a square matrix. If the matrix is not square, then it would not, we cannot further proceed. But if it is a square matrix, then we will check that if the transpose of A is equal to A, if it satisfies, then A is a symmetric matrix. Let's take an example. If M equals to 1, 2, 3, 2 minus 1, 4, 3, 4, 0, then you can see that it's a 3 cross 3 matrix. So it's a square matrix. And the second condition which I want to clear is that the transpose must be equal to the original one. Let's take the transpose. The first row would be changed into first column. Second row would be changed into second column. And the third row would be changed into third column. All of the things which are written horizontally would be changed vertically. Now the matrix obtained is same as like the above. 1, 2, 3, 2 minus 1, 4, 3, 4, 0. अरे ये तो जादू हो गया. Yes, when this jadoo happens, then it means that it's a symmetric matrix. Yes, this is the symmetricity of the matrix. Let's take another example. Example number 2. If A is equal to 2, 1, 3, minus 1, 2, 2, 3, 1, 3. This is our initial matrix. Now we are going to take the transpose of this matrix. Yes, I'm going to take the transpose. The first row is going to be changed into first column, second column, and the third row would be changed into third column. You can see that these are not the same. So these both are the square matrices, but which thing is not the same? The entry, second entry differs. You can see that this entry differs as well as this also differs. Tan-tan-tan. So we can say that A transpose is not equal to A. So A is not a symmetric matrix. Okay, now we will move forward. We are going to check the skew symmetric. Yeah. If this is a symmetric matrix, then what would be a skew symmetric? Let's know about the skew symmetric. Skew symmetric is basically all the same as symmetric matrix, but in which point we differ? Where there is a negative, there we differ. A square symmetric is said to be skew symmetric if A transpose is equal to minus A. Yeah, the first condition is that the matrix should be square matrix. And the second condition, the most important, is A transpose is equal to minus A. If the matrix is not a square matrix, then you cannot proceed further. But if it is a square matrix, then this condition would apply. Let's take an example. Zero, 2, 3. -2, 0, 1, -3, -1 and 0. Let's take the transpose of it. I'm going to take the transpose of it, changing the rows into the column. 0, 2, 3, -2, 0, 1, -3, -1 and 0. It's a 3 cross 3 matrix. And there is a difference. Oops. It's 2, but it's -2, it's 3, and it's -3. In the second row, -2, 2. 1, -1, -3, +3. -1, 1. So if we see there is a difference between the sign, how can we be able to make it a skew symmetric? Let's check it out. So students, you knew that negative multiplied by negative is always equal to positive. So here I use the phenomena negative multiplied by negative is equal to positive. If I multiply -2, it would definitely give me +2. So I done this. 2, 3 and 1 all are changed into negative and negative of 2, negative of 3 and negative of 1. Now, why I did that? I did that to take common. I'm going to take the common from these all. I took it. 0, 2, 3, -2, 0, 1, -3, -1, 0. I took the negative sign. Now I am going to compare this matrix with the initial one. As we see in the first row, 0, 2, 3 are the entries. -2, 0, 1. -2, 0, 1 are the entries of the second row. And -3, -1, 0. -3, -1, 0 are the entries of the third row. So it means that A is equal to A transpose is equal to negative of A. Or you can say it's the same meaning. A equals to negative of transpose. We can easily convert it like this. It's not an issue. So we did that for skew symmetric. Now moving further, we will know about the diagonal matrix. I told you previously that you should know the meaning, the definition of the type of the matrix by its name, diagonal. In any shape, these are the diagonals. So in matrix, the mid one is the diagonal. From this side, either you go or you can go from this side. Both of the sides are showing the diagonals. This is the diagonal and this is the diagonal in any shape. Yeah. Now the diagonal matrix, the square matrix. First condition is the matrix should be the square matrix. Means the order is number of columns and number of rows in that matrix would be equal. If at least any one of the entries of diagonal is not 0 and non-diagonal entries are 0. If diagonal is non-zero and all the other entries are 0, then it would be a diagonal matrix. समझ आया? नहीं. Let's take an example. A equals to 0, 0, 0, 0, 0, 1, 0, 0, 0. This is basically the diagonal of the matrix. In the definition of the diagonal matrix, they are saying that all of the entries except this diagonal would be 0. Except these three, all other would be 0. This, and this would must be 0. And what about the diagonal? In the diagonal, there must be one entry which is non-zero. Means that it would not be like this. It would not be like this. This is not a diagonal matrix. It's a null matrix. In the diagonal, there must be one entry which is not 0, which is except 0, 1, 2, 3 or else, but not 0. In this diagonal, 1 is the entry which is not 0. Okay, let's take another example. What about this matrix? Yeah, in this matrix, it's also a diagonal matrix because all other entries are 0 and the diagonal is non-zero. And what about this matrix? Is that a diagonal matrix or not? Yes, definitely it's a diagonal matrix. The entries which I first mentioned would be 0 are 0 here. And the diagonal have two entries which are non-zero. So it's a diagonal matrix too. They are the diagonal matrix of 3 cross 3. Now I will move to the scalar matrix. A scalar matrix who satisfy the conditions of the diagonal matrix. Scalar matrix. All other entries except diagonal are 0. And the third condition is that the diagonal have the same entries. For example, this is a scalar matrix of order 3 cross 3. This is a scalar matrix of 2 cross 2. And this is also a scalar matrix of order 1 cross 1. 1 by 1. Because the number is repeated. The order, number of rows and columns are same. All other entries except diagonal must be 0. The last type of matrix is identity matrix. What is the identity matrix? Identity matrix is the diagonal matrix, but it have 1 in its diagonal and all other entries would be 0. It's a 3 cross 3 identity matrix. A diagonal matrix is called identity matrix if all diagonal entries are 1, and the diagonal matrix, which is identity matrix, is always denoted by I. So these were all of the types which I discussed today for you. That covers the row matrix having only one row, then column matrix having only one column, rectangular and square matrix. Rectangular have number of rows and number of columns not the same, and the square have number of rows and columns both the same. Then we have discussed about the Skew symmetric, symmetric, diagonal matrix, scalar matrix, identity matrix, negative of a matrix, and transpose of a matrix. If you have queries about these all, you can mention in the comment section below. Please subscribe the channel for further videos, and if there is any problem, let me know. I would be